Hi, Cardinals. This is Mrs. Harmon. I am going to walk you through the guided reading for Lesson 4, Extending Your Knowledge, The Truth About Air. In the textbook, this is pages 58 and 59. We are going to take a look at the questions before we begin reading. We're also going to take a look at the reading in general. I see here, before I even look at the questions, a man standing on maybe a mountain or a woman standing on maybe a mountain. And it looks like maybe they're trying to show that the air molecules are spaced apart. Then I see a person here, and it looks like maybe they're on a beach and maybe the air molecules are closer together. I see that it's talking about air pressure, and weather. And then down below, it looks like it has some information about clouds. So now I'm going to go ahead and take a look at our questions that we need to answer. So on the guided reading, this is what your paper looks like. It says read and code the article. So we're going to read the article and draw attention to some important parts. Then it says to use the pictures to make a prediction, circling increases or decreases in the chart below. So at higher elevations above sea level, air density increases or decreases, and air pressure increases or decreases. So I could go back to that reading and I could look at these pictures and I can go ahead and make my predictions and circle what I believe. Then I'll go through, and these are the answers that I'm looking for as I read. Number 1, the weight of the water in a water tower is enough to force water where? 2, as the elevation above sea level increases, what happens to the air, column of atmosphere, and pressure air exerts? 3, how do clouds lower in the sky compared to clouds higher in the sky in terms of density and thickness? 4, differences in air pressure from region to region causing air to move is a definition of. 5, air flows from blank to blank regions. Air flows from blank regions to blank regions. 6, flip the example of walking into a cold building on a hot day to walking into a warm building on a cold day. In your answer, use wind, high pressure, low pressure, outside building, air outside, and rush in. 7, why can air pressure in any location on Earth change from hour to hour? 8, why is monitoring and predicting changes in air pressure important to weather forecasting? Okay, so now I know what I'm kind of expecting to be finding when I read. Going back to the reading then, I'm going to make this a little bit bigger for us. The truth about air. Why does a mountain climber sometimes need an oxygen mask? The higher a person goes, the lighter or less dense the air becomes. That means there is less oxygen for the climber to inhale. In this illustration, the particles of air are represented by dots. Where do you think the density of air is greatest? Could you make any generalizations relating elevation above sea level, air density, and air pressure? Air pressure. Water pressure is the force exerted by the weight of water on a surface. Think about that for a moment. Water is pretty heavy, 1 kilogram per liter, or about 8 pounds per gallon. The weight of water just sitting high in a water tower, which may hold millions of gallons, is enough to force water through faucets many miles away. So I think we just heard an answer there. Air pressure, likewise, is the force exerted by the weight of air on a surface. Air does have mass and therefore weight. At sea level, 1 square inch of air exerts a pressure of about 6.7 kilograms or 14.7 pounds. That is the weight of the entire column of the atmosphere rising above that square inch. As the elevation above sea level increases, the air becomes less dense, and the column of air above is shorter. This means there is less mass weighing on each square inch, and the air exerts less pressure. So I believe we just heard another answer. Air pressure and weather. Changing air pressure is one ingredient of weather on Earth. The formation of clouds, for example, is a direct result of air pressure. Low clouds, such as stratus clouds, are denser and thicker than clouds high in the sky. Clouds that are high in the sky, such as cirrus clouds, are wispy and thinner than clouds at high or are wispy and thinner than clouds at low altitudes. Differences in air pressure from region to region also cause air to move, which is the definition of wind. Air flows from high pressure regions to low pressure regions. If you have ever walked into an air conditioned building in the summer and felt a rush of wind against your body, you know that air pressure affects the way air moves. The difference between the high air pressure in the building and the low air pressure outside causes the air inside to rush out the door. In fact, it is being pushed out the door by the relatively high air pressure within. The same difference in air pressure created the movement of the air in your connected convection tubes. So that was another answer right there. Because air masses are in constant motion, air pressure in any location on Earth can vary from day to day, or even from hour to hour. I think that was another answer. Because pressure differences help scientists predict how air might move, monitoring and predicting changes in air pressure are fundamental to weather forecasting. And I believe that's an answer as well. I hope you have found this reading helpful. If you have questions, be sure to ask your teacher.